All right, so we're going to be working on this problem today. We're going to be trying to solve it for x, and we're going to be using some things that we know about rational expressions here to try to help us to solve this problem. Now, this may look like it's a little tricky and daunting at first, but once we get into it, hopefully it's not going to be too bad. At various points throughout this solution, I may ask you to just to pause and try it for yourself or to compare how you're working through it with the solution that I've got. Because of the nature of these problems, it's possible that you might be solving it in a correct way that looks different from mine, but be sure to be thinking about that while you're working on this. All right, all that being said, let's go ahead and just jump into it. Whenever I look at these problems, I always immediately think about combining these fractions and combining all of the numbers. But in order for us to be able to combine any fractions, we have to get everything under a common denominator. Now, you might be used to doing that with regular fractions, and it's pretty similar here when we're dealing with anything that has a variable in it. The one that usually may take people by surprise in this type of a problem is what to deal with this -3 here, right? I'm just going to go ahead and highlight it there for a second. So in order for us to be able to combine this -3 with the fraction that's on this side of the equation, we need it to have a common denominator. So take a second and think about what type of a common denominator you would need. I'm going to give you a second to think about that while I start recopying this equation for the next line of work. All right, and now we're at the point where we need the common denominator, so hopefully you got that it was supposed to be x plus 2. And what we're going to do is we have to multiply this 3 by x plus 2 over x plus 2, because that's effectively like multiplying it by 1. And you might have also noticed that I like putting parentheses all over the place in this problem, and part of that is just that it's an easier way for me to be able to take care of things and keep things straight, like this minus sign and just some various operations that we're going to be doing as we keep going forward. So you don't have to have the parentheses, and remember they're eventually going to go away once we multiply things out, but it's kind of useful just to keep track of things. All right, now that we have this common denominator here, we can actually do a little bit of cleaning up on our right side of our equation here. So you're going to want to make sure that you take care of things like distributing out this 3 here, right? Because you're going to be combining everything on that right side. All right, so let's see how that's going to look here. On the left side, nothing has changed, so I'm just going to go ahead and copy that down again, that 2x plus 8 over x minus 3. And then over here, what I'm going to do is I am going to say that this whole thing is now going to be over x plus 2, right? They both have the same denominator, so I can now do that, right? And then I have still this -x minus 1. And then after I distributed that 3 out, I have 3x plus 6. Now, I only distributed the 3 and I didn't distribute the negative, so be careful with that, right? I still left that negative sign right here, right? Okay. All right. So I may do this in more steps than you might be when you're solving this yourself. Mostly it's just I want to explain every single thing that I'm trying to do. You might be more concerned about getting it done faster, which is totally fine. So what we're going to do next here is clean up that right side a little bit more. I have to keep bringing down the left side here because nothing's changing with it. I could just leave just an equals here because it's not changing, but I don't want you guys to think that I forgot about it, right? So on this left side, we now have negative x minus 3x, right? We're combining our like terms, so that's going to get us negative 4x. And then we have negative 1 minus 6. So again, with our like terms, that's going to give us negative 7, right? And that is going to be over x plus 2. All right, so we've already made quite a bit of headway here. You might be asking yourself what we're going to do now, right? I think some people might think that, oh, we've got two fractions that equal to each other. I'm going to treat this like a proportion and cross multiply or something along those lines. We have to be very careful about doing that in these types of problems because there's no guarantee that the denominators are not actually equal to 0. And multiplying or dividing by 0 when you're trying to solve equations is a great way for everything to go haywire. So because of that, we are just going to subtract one of the rational expressions from the other side so that you're going to have this whole left side be equal to 0. So I'm going to go ahead and subtract this fraction on the right side, this negative 4x minus 7 over x plus 2. I'm going to subtract that from both sides so that I can get something that is going to be a little bit nicer for us to solve. So again, still got to keep that 2x plus 8 over x minus 3, and now I'm subtracting negative 4x minus 7 over x plus 2, and this whole thing is going to be equal to 0. Now, this next part could be a little bit of preference. One of the things that you could do now, just to make things a little bit nicer, is you can go ahead and you can actually distribute out this negative sign here into our function, right? This is, remember, a negative. It's the same thing as that this fraction is being multiplied by negative 1. So if we do it now, it's possible that it won't end up throwing us off later and causing us to be off by a negative sign. All right, so let's just move it here on down. So now we have, here we've got our 2x plus 8 over x minus 3 plus 4x plus 7. Remember, we distributed that negative sign. And then still over x plus 2. And this is going to be equal to 0. So now, what is it that we need to do, right? You know, we've already gotten to this point here after combining those. Let's see, we'll go back up for a second here. We combined these fractions on the right side initially, and then now we have reached the point where we only have these two fractions left on the left side, and we still haven't solved for x yet. So what we have to do now is get a common denominator again. So in order for us to have that, we have to take a look at what are our two denominators that we have. We've got x minus 3 on our left fraction and x plus 2 on this one on the right. And we need some sort of common denominator between the two of them. One of the strategies when we're trying to find these is to multiply the denominators together, and that is always going to get us a common denominator. It's not always going to be the lowest common denominator, but in this case, that doesn't really matter as much to us. So that means that our fraction on the left, we're going to have to multiply by x plus 2 over x plus 2, and our fraction on the right, we're going to have to multiply by x minus 3 over x minus 3. So we'll go ahead and start writing that out here. So I now have 2x plus 8 times x plus 2 over x minus 3 times x plus 2. And then my other fraction, this is going to be 4x plus 7 times x minus 3 over x plus 2 times x minus 3. And now we can see, even though I ended up changing the order on the denominators, those are both equal, right? So they both have the same denominator now. And we might be tempted to multiply everything out and turn them into just quadratics, but that isn't really going to help us with the denominators. However, it will help us with the numerators. So that is what we are going to do next. So I can now take, let's see here, I'll still end up having this 2x plus 8 times x plus 2. I haven't multiplied them out yet, and then plus 4x plus 7, and then times x minus 3. And this whole thing is now over x plus 2, and then x minus 3, right? And then, again, still equal to 0. All right, and now we are going to just go ahead and do our multiplication out of these binomials, right? We can't really combine anything yet in regards to that plus, but we can do, whether you want to call it distributing or using FOIL, if you're familiar with that procedure. We are going to be multiplying these pairs of binomials here in the numerator, right? So that's going to end up with our first pair getting multiplied out here. So remember, this means that we have to multiply out all of these pairs of numbers, right, here. And once we do that, we end up with something like, let's see, 2x and x is going to get us 2x squared. 8 and x is just going to get us 8x. 2 and 2x is going to get us 4x. And then 8 and 2 is just going to get us 16. All right. So we've got that. And then on our other side, we're going to still multiply out these same things. And let's see, those on top, and this one here, and this one here, right? So when we do the same thing as we did on the left side, that's going to end up getting us what? 4x squared from 4x and x, plus we're going to get a 7x in there. And then don't forget that this is still a minus 3, so that'll get us negative 12x. And then we've got 7 and our negative 3, which will get us negative 21. Now I'm starting to run out of room here, so I'm just going to zoom out a little bit to give us some more space. And then let's see here. We want to set this whole thing still equal to 0, right? That hasn't changed, remember. And our denominator hasn't changed. It is still x plus 2 times x minus 3. Don't forget the end of that parentheses, right? So now what we've got here on the top is we've got some like terms that we can combine, right? We don't have any more multiplication going on up top, so we can now drop those parentheses and just combine like terms among both of those quadratics. So let's just move to a little bit more white space here and work on doing that. So why don't you take a second and try to combine those like terms on your own. I'm going to go ahead and just get things ready so that we can combine them here. But, you know, if you need a little bit of extra time, you can always just pause, and then we'll be ready to move on with the rest of the problem. So I'm going to assume that you either paused it or you were able to combine those like terms in the numerator in this amount of time. So what we're going to start with first is we're going to get those squareds up there, right? So we're going to combine this 2x squared and this 4x squared here, and that's going to get us 6x squared, right? And then now the next one that we need all of the x's, right? So that's going to be 8x, 4x, 7x, and then our negative 12x, right? Well, let's see, if we combine 8x and 4x, that's 12x. And then our negative 12x, well, those will end up canceling out, right? So actually, all that we have left after we combine those four is just regular old 7x, right? And then the last thing we have to do is just combine our constants. So we've got our 16 and our negative 21. And that is going to get us negative 5. All right, so we're getting to the home stretch here. All that we have left to do is factor our quadratic, right? Because since we have this set equal to 0, with our fraction here, the only way that we can have this fraction be equal to 0, based on stuff that we're plugging in for x, is if the top part is equal to 0, right? Because if our denominator is equal to 0, well, that's bad, right? We can't divide by 0. So all we're concerned about now is factoring the top and finding out when that is going to be equal to 0. So in order for us to solve this one, you might notice that the coefficient in front of our x squared is not 1. So that doesn't make this quite as easy as it could be. I'm going to approach this with a little bit of factoring by grouping or AC method, but the main thing that we have to look at here is we have to look at this number and this number, and we have to say if we multiplied these two, what would we get, right? 6 and negative 5, and what we would get is negative 30, right? So since we get negative 30 as our answer, we have to look at, okay, what are numbers that multiply to get negative 30, but when you add them together, you get 7, right? And that 7 just comes from here. So we want to multiply to negative 30, but add up to be 7. So take a second to think about it. I'm going to just go ahead and I'm going to start writing the next line. And then when we get to that part, hopefully you've got something that you came up with. All right, so I've got this all ready to go. So hopefully you got 10x and negative 3x as your answers, right? So what we're going to do for that is I'm going to split up this 7x into negative 3x plus 10x. We can do that because if we just combine them back, negative 3x plus 10x, we'd get back to 7x. So we haven't really changed anything, but this is going to make factoring it a lot easier, right? We're going to be able to factor this by grouping here. Okay, so now we're going to start factoring this by grouping. So we're going to slide down a little bit here, and then I'm going to put some parentheses around these here. Really, we're kind of grouping these guys, right? And we want to look at common factors that we can take out of each of these, right? So think about a common factor that you can take out of the first pair, and then a common factor that you can take out of the second pair that 6x squared minus 3x, and then the a common pair for 10x minus 5. And once you do, we'll be able to take care of the next part, right? So hopefully you were able to find that 3x happens to be in both of those first two terms. So that gets us 3x times 2x minus 1, right? All I've done is I factored out 3x from the 6x squared and from the negative 3x. And then in the second set, we're able to factor out a 5 in both. So this gets us 5 times 2x minus 1. So it looks like we did things well. We chose the right numbers because, hey, we've got this 2x minus 1 and this 2x minus 1 here. So these are now common factors in on the top here. So just like we were able to pull out 3x and 5, we can pull out 2x minus 1 as a common factor. So that's what we're going to do here with this next one. And that's going to get us to have 2x minus 1 times 3x plus 5 on the top. And then x plus 2, x minus 3 on the bottom. So all that is going to be left for us to do is find out when the top is equal to 0, right? How do we do that? We just have to set each of the individual ones, 2x minus 1 and 3x plus 5 equal to 0, because since the two binomials are being multiplied on top, if one of them is going to be equal to 0, then their product is equal to 0. So we only need one of them to be equal to 0. So that's what we're going to do now, is find out when those are the case. So we're going to go ahead and just solve these last little equations here. And this is going to get us, let's see, 2x equals 1 after we add 1 to both sides and then divide by 2. It's going to get us x equal to 1/2. And then over here we're going to get 3x is equal to negative 5. And then x is equal to negative 5/3. So those are our solutions, right? The only one thing that we have to check is to make sure that both of these x's don't make our denominators equal to 0, right? Take a look at our denominator of x plus 2 times x minus 3, right? What are the values that make that equal to 0, right? It's going to be negative 2 and positive 3. So that's part of the reason why I never ended up multiplying out the bottom, is because it's easier for us to see the numbers that are not in the domain in this problem. We can see that negative 2 and 3 would get us 0 in the denominator. Since neither of our answers are negative 2 or 3, then these are both good answers. These are good x's that will work for this problem. So that is how we can go about this problem. Now, obviously, I took a little bit longer with some explanations, but these problems are a little bit tricky. I hope that you were able to get a little bit better understanding of how to solve them, and if you want to see the solution typed out without all of these directions, there is a link to it in the description below.